Okay, let's pay attention now, okay, Conrad? Thank you. Thank you. I know you're talking math probably. What's the correct domain for this function? This one right here. So you need to have on your study sheet, okay, listen carefully. When it comes to exponential, you should have a non-contextual scenario, right, where your graph either does this or something like this, okay? But it never ever crosses the x-axis when it's exponential. When it's a word problem, you may have a scenario where we have something that grows, right? Time starts at 0, it grows. Or we have something that is up here and then it decays, right? So from a non-contextual to a contextual, you kind of expect one of these two scenarios. How do we know that? This will have b greater than 1, and this is where b is between 0 and 1. That's for exponential. Okay, so we are now in this scenario. There's no context at all here. So for this, it's all real numbers for domain. So we want this. For range, this one doesn't work. So you would actually pick this one, right? C is your correct answer in this case, because the range goes from 0 but not inclusive. It's just the bracket that makes the difference, all right? All the way to positive infinity. Which equation would have been used to create this graph? So we know emphasis on the x-intercept, okay? It cannot be exponential. There's like it's ruled out. So all the exponentials, if they're there, they're out of the question, right? So you're basically down to that. And again, for logarithmics, you either have, right, this is your asymptote. You will either have this happening, okay? That's if b is less than 0, it's negative. And it will do this if b is positive, okay, bigger. So we're seeing something that's decreasing, right? So we're wanting b to be negative. This is b right there. So the answer is D for this one. And the reason I'm explaining it, because I don't care just the right answer right now. Of course, that is good, you should, but right, you could be faced with various circumstances that you need to be able to tackle, right? I could change this test just by changing the graph, keep all of these options open, and it's a completely different test, right? So there you have it. For this one, determine whether it's exponential or logarithmic. And to be honest, I haven't put this into my calculator right now, but the scatter plot is curving down, not up. It's flattening. It should be a logarithmic function. This should be a logarithmic function. Yeah. Anybody disagree? Nobody disagrees on this one? Okay. Again, I told you I was going to tell you which ones to use moving forward, but there was a time where that wasn't the case. You know what? I will come back to this later. I'll take some time to type this in and then come back to that later. If you disagree with me, that's fine. I will tell you why once I look at the scatter plot. The equation of best fit, if you go stat, calc, natural log regression, it is 9.48 plus 125.45 natural log of x. Okay, that's what the equation is supposed to be. And okay, let's just look at, I'm just looking at these numbers here. As x is going, like when I'm at 2, it's at 97. At 9, it's at 200. It's kind of it's flattening like this, right? If I just look at these numbers, I kind of see this pattern right here. So that's why I chose logarithmic there. Because exponential, you want something that starts up here, goes like that, or starts up here and curves up. You want the curving up when it's exponential. You actually see something that's flattening this way, right? So that must be logarithmic for that reason. So without a calculator, I could already predict that. Determine whether it's exponential or logarithmic. This is probably, what do you think? You think it's exponential, but 5, let's see here, 5, 25, 10, 15, it's doing this, right? Oh, this is the giveaway right here. 30, you're at negative, right? So what does that mean? It crossed, right? So it cannot be an exponential. It absolutely cannot be exponential. So that's why this is logarithmic. Okay? Has an x-intercept, therefore can't be exponential. So use your your knowledge of the functions to kind of rule out. And so therefore the equation, if you do natural log, is this. It turns out to be 50.00 and 15.00. Okay, so that would be good enough. So 1 mark for everything, right? Every part it gets 1 mark. I would say don't be too gracious today. Rather be a little harsher. 5, next page. Okay, so here you have an investment where T is the, I want to go back to this. This here is your X variable. So in this case, time, T stands for time, and V is for the dollars, right? Value. So every point is X, Y as follows, right? What's the initial value of the investment? It is given, right? Given by the 5250. Okay? This is the initial amount. Initial amount, which is 5250. Something along those lines, put a unit around it so that we actually know you understand what's happening. If you rather want to say, hey, I know that this is exponential, and in general, an exponential function looks like this. A is what gives me the initial value. A happens to be 5250, therefore $5,250 is what I have to start with. What is the percentage growth per year of this investment? Because it's greater than 1, I just go 1.0375 minus 1. So this is what it is as a decimal, but it is 3.75% per year. Okay, so this is what I'm after there. So when it's bigger than 1, you know it's increasing. You just go subtract 1 from it to get your percent increase. If this is less than 1, then you go 1 minus that to figure out the percent decrease per year. Okay. Determine the doubling time. In years of the investment, express your answer to nearest hundredth of a year. What is the doubling time? It's how long it takes, right? How long it takes for the money to double. So you start off with 5250. So you want to draw a line that is twice of that, twice what you had initially. What do I have? That is 10,500, right? That's the line there. So you would go y2 is equal to 10,500, and obviously you have to play with your graph, make sure it all fits on there. Then second trace intersect. Sorry, it's a little chicken scratchish today. 18.83 years is your doubling time. Yeah. Just take a rounding error off, just because it says round to the nearest hundredths, right? So time is always okay. Like if it's how long, even if it's days, you can have decimal of days. Yeah. What did I want to say here? What does this mean? Okay. What does that number mean? If I asked you, what's the 1883? You're like, well, it's a doubling time. Of course. So I want you to know in particular that every 18.83 years, your money is going to double from what it was before. So the pattern is 5250, and then we get to 10,500. What would be double of this? That would be 21,000, right? So every time this happens, 18.83 years go by. Okay, so every time 18.83 years go by, you double your previous amount. So that's what you're trying to find. I would expect you to know that if I asked you to explain what that number represents. And half-life is doing the exact opposite, right? Every time that time goes by, you're down to half of the previous. This one threw some of you off, but hey, this is totally exam material. So there's a logarithmic scale for measuring the intensity of earthquakes, and this is the equation that that relates those two. What is E? That's your x variable, okay? And M is my y variable. E is the energy in gigajoules, and the M is the Richter scale, right? Yeah. So get this right to be successful. Get this right. And this is what threw some of you off, right? Some of you asking, what is this? What is this? A gigajoule is billions of joules. It's how many, like 1 gigajoule would be 1 billion joules. So this is just explaining what that unit is, okay? But this is the unit, and it's right there. That's the unit right there. So note that a 0 in a Richter scale is considered the minimum detectable earthquake, and a 9.5 is the largest recorded earthquake. So knowing this, what's the measurement? On the Richter scale, that would have an earthquake that releases this many gigajoules, this many billion, okay, of joules, that is. But we're talking gigajoules, so we're in line with the units that were given. So they're basically saying, if this is 180,000, what is the Richter scale there? So we would go second trace value, x is equal to 180,000. It's probably a little bit of a trek to find your window, correct? I will do this with you because I feel like you probably need a bit of guidance here. 0.6667 log. So you got to be careful you don't go natural log, and it's just x every time, okay? Oh, I just have a straight line. That's not good. So I'm going to try, I know that 2.8 is part of it, and I know this is increasing. Okay, so there's a few things here. So I'm going to try a zoom fit. Let's see. Zoom 0. That's much better. So often it comes to your rescue. And if it doesn't do the trick, listen to this part. Zoom 6, right? You do a zoom standard to reset your window from what you had used previously. And then you try zoom fit to help you out there. Okay, and I want to make sure that my Y min is a little bit into the negatives. Y max, I'm going to go higher as well. There you go. For now, it's good, but I need 180,000 to fit. So my X max needs to be 200,000 or something like that. So second trace 180,000, and there it is. It's 6.30 is the Richter scale right there, magnitude. Okay. Determine the amount of energy released by an earthquake with a magnitude of 5.5. So now it's the other way around. They're asking, what is this if this is 5.50? Right? You just let Y2 be 5.50. Second trace intersect. And I'll just tell you what that is. That is 11214.95 gigajoules. Okay, that's what you're supposed to get there. How many times more energy is released by an earthquake that measures 7 on the Richter scale compared to the one that measures 5? This one isn't quite fair because I haven't talked about this, so you're not going to lose marks on this one. But you let Y2 equal to 7, second trace intersect, okay? And you get that X is 199 3815.7. Okay, so 1 million something gigajoules. Yep. The way this works is you wanna take this and you wanna divide it by the previous one. That's how many times. That's how many times more powerful it is. You want to see how many times this fits into the previous one. So I'm not taking marks off if you didn't do this part. If you have this, we're in business, you're going to get the mark, okay? So this will be 177.78 times as much. That's how many times more powerful it was compared to the previous one. Right, because you're comparing the energy released. This is the energy released by a 7 scale. This is how much energy was released by a 5.5. So this will answer how many times more. Okay, but we didn't talk about earthquakes, so it's okay. On this one, I wouldn't have expected you to know that. So how many marks are there on this page? If you're keeping track, 1, 2, 3, 4, 5, 6, 7. If you're not sure, that's fine. I would appreciate you marking like X's or circling what happened. That makes it a lot faster for me. Let's go on to the next one. What's that? How is it 7? 1, 2, 3, 4, 5, 6, 7. Like if I add up. If I add up this, 1, 2, 3, 4, 5, 6, just this page.
Do we lose marks for not putting keystrokes?
Normally I would, so let's just say a maximum of half a mark per page. But put a K, every time you forgot, put a K down. Yeah. And this is another reason why you want to have that, okay? You want to have it in case you make a mistake, okay? So if we see that you're doing this and you come up with a different answer, you may lose full marks on this one, but then you won't lose thereafter. You know what I mean? Because we figured out you must have entered the wrong equation. Something went wrong, and so that's a trail to make sure you honor your marks, okay? Okay. We good? 7, a graphing one. Iodine is a radioactive substance used to treat thyroid cancer. The percentage of iodine in a dose given to patients is based on the following equation. Is this a what? This is exponential, and it is increasing or decreasing? Decreasing, because it's less than 1. So you know it starts somewhere here, and it's going to find its way towards the x-axis, never crossing it. What goes on the x-axis? Time, right? Time, and percentage remaining goes on the y-axis. So get that out of the way. Make sure you understand that. So here we go. Make the graph. I will do this with you so you have no excuses that I didn't show you how to graph these, right? Decreasing ones are trickier, but we'll go time, and you have to say what? It is hours, okay, to get full marks. And then this is percentage remaining. I'll just put that down. And I need to figure out how I'm going to work with this. It says to graph over the period of 1 month, 720 hours. So that should give you a pretty good indication as to what scale to use. Okay, so 100, 200, 300, 400, 500, 600, 700. There we go. And what should this be here? How high do I need to go here? 100 is like my initial amount, right? That's my y-intercept, so definitely 100. If you go a little bit higher, that's good. 20, 40, 60, 80, 100, okay? So I'm gonna go to up to 100. So let the y-intercept tell you what that should be. So I go from here for sure, and I'm gonna inch my way to the ground. I'm gonna do this, second trace 1, and I'm gonna do this for several x values. I'm gonna go 720 in particular, because this question is interested in that. At 720, I'm at 7.45, okay? That's my y value. And I did a couple of other ones. I went x is equal to 200, where y was 48.61. So a few reference points. So 720 is right here, and then I'm at 7.41, so I'm really close to the x-axis. At 200, I'm at 48. So that's right about there. That's good enough. Should you put an arrowhead here? Yes. And I'm done the test already. If I say something like this, I will just say it doesn't end there. I will just say I want you to include up to 720 hours, but it doesn't end there, so you know whether or not you have to put an arrowhead or just put a dot where it stops, okay? Is everything else good? Yeah, we're good. What percentage of iodine remains after 10 days? What do you need to be careful with here? Days, and this is time and hours. So read carefully. So 10 days, that's 240 hours. And so that's my x value, right? So you just go second, trace, value, x is equal to 240, y is equal to 42.08%. So there's 42.08% remaining in the body after 10 days. This is somewhat accurate. I wouldn't say exactly, but I try to make it as real as possible. What is the half-life? Okay. Half-life means where y2 is equal to half of what you started. Okay, folks, so just pay attention here. If this had been, right, 2,000, then you would do half of 2,000, right? Whatever that initial amount is, you go half of that, and then you find the intersection. And you know what? I would have expected you to have tried all of this. You had quite a bit of time to do that. So make sure you stay on top of your work. This isn't going to just be a piece of cake, right? 192.19 hours. That's the time right here that you need to include. And obviously, if you graph this anyways on your calculator up to 720, then this should be no problem at all to get to 192. How long will it take until only 1% of the original amount is in the body? Okay, y2 is equal to 1. Remember, that is in percentages, so we don't need to divide this by 100. So those are things you're going to have to figure out as you go along. If you do divide this by 100, your answer will be pretty ridiculous probably, right? So you kind of have to maybe let that guide you. This is 1276.91 hours. Okay. Does it say in months? How long? No, it doesn't say in months or anything. It just says how long. So we assume we're going to stick with hours. Okay, we're almost there. How many marks? Sorry, 7 again. 3, 4, 5, 6, 7. Yes, 7 marks for this one. And the mark allocation is not quite exactly the same as you're gonna have on the test, but the last one, 1276.91. You got that? Oh, yes. I'm rushing a little bit, but yes. Good question, stop me. So to get full marks, yes, the province would expect you to have a label, a title, or the equation. I always prefer the equation. If I have to choose, I always go with the equation because I don't know what to name it, right? So just put the equation down, you're fine. So half a mark off even if you forgot the units for time, that would be half a mark deduction. Things like that. Keep going. It becomes easier and easier to see the headlights. This is an old exam question, just a little twist to it. To see the headlights of an oncoming car closer as it gets closer, the distance between the car and the observer can be described as a function of intensity of the headlights brightness. So here you have it's a logarithmic, and you know that I is your x variable and d is your y variable. Okay, so we have that figured out. Sketch a clearly labeled graph. So let's do that. Is this, which way is this going, folks? Let's just do a little sketch on the side here. It's logarithmic, and b is negative. So what do I expect? I expect this, right? And it's going to hit the x-axis at one point. So that's what we're looking at. That's what we're looking at. So I'm going to find that x-intercept. Should I graph this with you? I will. Okay, I graph it. I'm going to zoom fit. There we go. And I'm going to make sure my y min is too low. I'm going to go like this. And my y max is also very low. You need to go? Fit. Yeah. What do I do with the y max, folks? That's where I use the fact that 1b is part of it, right? So 350 is in there, run and 350. So I'm going to go 500 there. Okay. Whoa, what happened? X max is too big, eh? I'm going to try something here. There we go. X max 150? I'm going to go with that. Yeah, that's a pretty good one. You see how it's a bit of playing around with your calculator. And you all love texting, so it's just a bit more of that, right? And then you got it. So I'm going to find my x-intercept here real quick. So y2, 0, second trace. And if you have the work done here, you don't have to do it again later on. Okay, 129.170 is as far as I can get here. And then it's going to go towards my y-axis. So this will be intensity in lumens. And this would be the distance between the car and observer. Distance, and that would be in meters. There we go. So you've got your x and y labeled. I need to accommodate 129. So I'm going to try something here. 20, 40, 60, 80, 100, 120, 140. That's just fine there. So 20, 40, 60, 80, 100, 120. Okay, so I'm going up by 40s every other mark. Is that correct? Oh, this should be 120 here. Should be 160. My bad. Yeah, and how far do I go up here? I would say at least 400 or 500 or something like that. It doesn't have to. It doesn't indicate, so we're just going to go 100 at a time here. So 1,350 is going to be on there for sure. 1,350. And then 129, this is 140 here, so 130, 129 is right about there. And I found one more point. I found 20 and that was 134 using the calculator. And then you just go from here towards that point, you curve up and just make sure it doesn't touch your y-axis. And then you just put the equation on there. And you've got yourself a graph. Determine the distance to an oncoming traffic if the intensity of the headlights is 75. So what am I given here? I already know that intensity represents my x variable. So that it's in a sense saying 75 question mark. Okay? So we go second, trace, value, x is equal to 75. Y is 39.14, and what are the units in? We're in meters, right? Because it's the distance between the observer. That's pretty close. I would already run at that point if I were the observer. What is the maximum intensity of the headlights? Justify your answer. Intensity is along the x-axis, right? So what's the maximum intensity in this case? It's the x-intercept right here. So it's 129.170. So maximum intensity is 129.17 lumens, okay? Because the distance between the car and observer is 0 meters at that point. Sorry, I know it's way further down here. So what does that mean? The car is literally hitting the observer at that point. After that, you're going to see a different kind of lights. Right? You're going to see the light. But that's as close as you can get. Like, that's the maximum intensity that can be observed. And then you're no longer. Okay, so don't do this. Okay, this is just to think about. If I asked you for the domain and range, because let's face it, that's always going to come and get us, right? What would you do for the domain in this case? Domain, do we start? Does it ever touch the y-axis? No, correct? So it'd be 0 all the way to 129.17 square brackets. Right, so you go from 0, we do state 0, but we don't include 0. I would add this to my quiz. Well, feel free to do that with a pen or something. What about range? The range is the distance. It does get as low as 0 and as high as infinity. Right? Like according to this model, you can see the light from super far infinity distance away from you. And if you've ever been in a very dark in the forest at night and you see a tiny little flashlight kilometers away, you will see it. But not infinity. Infinity technically wouldn't make sense in the real world, but in this, according to this model, we're not told otherwise, so that's what we state. Okay? Okay, doubling time, I think. We get to the doubling time. This is very important. This is a classic exponential function scenario, right? So question 9. How many marks for this page? Let me get that right. 3, 4, 5, 6. Yeah. You got it right or what? How do you know? You just know, right? Oh, you went logs or what? Well, can I say, like, let that be a lesson? So for doubling time, it's exponential, okay? And this is the reason why you'll see a y-intercept on it. So when a person gets a bacteria infection, bacteria are like the go-tos here. I'm thinking logarithmic. You know what a good logarithmic would be? I was having coffee the other day, like as time goes by, the temperature drops, but it won't get to 0, right? Unless you're outside. If you're in a room, it kind of will just flatten to the room temperature. a person initially infected with 12 bacteria, and it's doubling every 3.5 hours. So here we go, time and bacteria. At time 0, you have 12. 3.5 hours go by, 24. Another 3.5 hours go by, 48. You can stop at that point. Create a table of values, at least 3 doublings. Okay, fine. So this is one, right? 1 doubling, 2 doublings, 10.5, and this would be 96. That's for, I'm not going to take marks off. I mean, you should have followed the instructions, but this is what you get a mark for having those. Determine the equation that models the number of bacteria as a function of hours. So you put this into L1, you put this into L2, and then you go stat, calc, exponential regression. And here you got your equation, which is 12, no surprises there, 1.2190 to the power of x. Got it? I want to say something about this one. You need to be able to also put this together. Listen carefully to this part. If I said someone's body has 12 bacteria to start off with, and it's growing at a rate of 21.9% per hour, you should be able to put it together like this. 21.9% per hour increase, right? You would just go 1 plus the percentage as a decimal to get that B value. And obviously this is just what you start with, right? So I'm expecting you to know how to put it together just based on me laying it out for you with all the pertinent information. How long will it take until there are 10,000 bacteria present, assuming that the immune system hasn't slowed the growth of the bacteria up until that point? So remember, it's time bacteria every time. This is bacteria, so y2 is equal to 10,000. Second, trace, intersect. See, you can even do chicken scratch. I'll read it. And that's 33.96 hours. That's how long it would take under these circumstances. So, Sean, I'm not picking on you. I'm just because you told me, shouldn't have told me. You use log, right?
Yeah.
I would still honor this answer.
I got that.
You got this answer?
Yeah.
Yeah, because they're trying really hard to model. But did you use this point? Did you have 0, 12?
Oh, I mixed it up.
Oh, you did it the other way.
Yeah.
Because if you put 0, 12 and then you try to do a log, yeah, if you try to do a log, it will give you an error because it cannot have a y-intercept. Yeah. So this page is worth 1, 2, 3. Should have snuck in another question there. Okay, we're almost there. 10 green marbles and 6 white marbles are placed in a container. Do you remember this one? Please have this on your study sheet or remember it or do whatever you need to do to remember this. Same of something to the same. So what you do is you need to do or, right? Because you've got white and green. So you can have the option of having the same would be green, green, or white, white. Those are your options. So you can do combinations or you can do it this way. Green, green would be 10 over 16 times 9 over 15. Okay, because you're taking one out. So you're down to 9 green ones out of 15. Or if you do the white ones, it'll be 6 over 16 times 5 over 15. Like so. I believe. Yeah, I got it. So this first part right here gives you 90 over, I didn't do it that way, so I'm just going to quickly, 16 times 15. I know that 15 times 15 is 16 times. It's 240 plus, this would be 30 over 240. So that would be 120 over 240. And this is good enough, but if you went as a decimal, that's good too. And if you went percentage, that's good too. Okay. So I would say if you didn't do the cases, you take off a full mark. If you didn't do the or. And then the rest, I would just honor that. Yeah. Did you do comms? Yeah. So you can do, out of the 10 green ones, you choose 2. And out of the 16, you choose 2. That'd be your first one. Or out of the 6, you choose 2. And always 16, choose 2. Is that how you did it? Yeah, you get the same answer. Yeah. I would say both are just fine to use. So you just have to be careful. Mr. Erickson's choosing a random. I don't have this answer because I think, oh yeah, I do have this one. Is choosing a random group of 3 students from his class where 18 girls, 11 boys. What is the probability that this, and emphasis on probability, okay, that random selection will have at least one boy in the group? You want at least one boy. So what we're going to do is we're going to figure out the total. So from the 29 people, right, 18 and 11, we're going to choose 3. That's the total. And this is NU. This is my universal. And we're going to, from that, take away the group that has no boy, right? All girls. So from the 18, we're going to choose 18 girls, all 3. And from the 11, we're going to choose none. Okay? So we're taking away the groups that have no boys in them. Out of 29, choose 3. So this is your universal here. So we're taking that away. 29, choose 3 is 3654, yeah. And so it's 3654 minus this one right here. What is it? 2838, this part. 2838. Yeah, and that leaves you with 86. No, I'm doing something wrong here. I'm just going to check this. 18, choose 3. So this is 816, right? Did you give me the final answer? Yeah, by any chance? I may have done this differently than you, but this 18 choose 3 is 816. Yeah, so when you subtract it, you get 2838 out of 3654. So there you're fine. If you did it as a decimal, it's 0.7767. So either one is fine. And I know I threw this one in, it may have thrown you off a little bit, but it's a I want to say something about this one. It's a cubic right there because it's volume. Anytime you have volume, you know it's a cubic function. You should write it down nice and big because if that ever shows up, you should be comfortable with it, okay? And I'm going to type this into the first thing you should do is type that into your, you should all do that if you didn't do this, just to, walk through the process. And this will be 30 minus 2x. So if you think about it, if you were to multiply this all out, you would get an x cubed out of that, right? And so I went I'm going to go zoom fit, and it's not the greatest. I'm going to go zoom standard first. There it is. I see it doing this. And that is the part, listen carefully, that is the part you want to focus in on. You want to focus in on where it goes through the origin, and in this first little cap, that's the only part you care. I know the cubic does this whole thing like this, but for volume, you just care about that little cap. So I'm going to go to my window. I'm going to go negative. I'm going to go 20 here. It's way too far down, right? It tried something. Let's try this again. There you go. And we just care. Look up here. Make sure you remember, for volume, this is the only part we care. We don't care, as soon as it dips below, negative area is not even an option, and all of this is also not applicable anymore. So yes is cubic, but only for that part right there, okay? The first little hump. So, determine the maximum volume. You find the quote-unquote maximum there, not vertex. Vertex is very specific to a parabola, okay? This is the max. So we just go second, trace, max. I know I have the key here somewhere because I added this after the fact. This wasn't part of the original test. Anybody do this? What is it? 3.92? 1056.31. So, oh, sorry. 1056.31. Okay, so the maximum volume, don't leave it there. Volume is 1056.31, and we are in centimeters cubed. Okay, so the idea here is every time we cut out a square, the height of this box is going to be affected, right? And so is the volume. So in this case, the x is like how much we're cutting out, that piece, that square that we're cutting out. So in this case, if a square of 3.92 by 3.92 is cut out, you're going to get a box with a maximum volume of just over a liter. A liter has 1,000 cubic centimeters, right? So, what is the height of the box that would yield the maximum volume? Right here it is, 3.92 centimeters. I just got it from the previous question, and there it is. State the domain and range in this scenario. Again, let's make a little sketch here because I find the graph. It's only like once it stops there, this part right here, you omit, okay? Ignore. You're only going to have your domain from here to here, and your range is going to be from here to the highest point. So for the domain, it goes from 0 to, what is it? 10 exactly. This one right here, okay, 10. And the range goes from 0, right, 0, all the way to the maximum volume, which is 1056.31. 1 mark for each. Okay. And the magic square. On top of everything you need to know. And they tell us you cannot prepare you for it. That's what they tell us, literally. Like, hey, give us some stuff so we can prepare you. It's like, you're not even really supposed to prepare you for it. But every exam is going to have one question at the end with some sort of puzzle game or fun activity. A magic square seems to, like quite often a magic square is what makes it. And so I hope you read this, but what is a magic square? It's a square where no matter which way you go, you have the same sum. So it goes this way the same, this way the same, and even the diagonals are the same. And so you can only use numbers 1 to 9 exactly once in this particular case, so that there's a common sum of 15. So this, if you think about it, 8, 5, and 2, that adds up to 15. So this one is, obviously that's good. So let's use the ones that already have 2 boxes filled in. 8 and 1 is 9. So what's the only other number that would work? 6. Can't use 6 anymore. Okay. 1 and 5 is 6. So this must be a 9. Okay. So check. And now fill in the rest. 6 and 2 is 8. So this must be a 7. 9 and 2 is 11. So this must be a 4 to make it 15. 8 and 4 is 12. So this has to be a 3 to make that 15. So let's check. 6 and 5 is 11 and 4 is 15. So you got 15 here. You've got 15 everywhere you go. So that is what we call a magic square. Quite often, like I've never seen them give you a completely blank one. Never. It's always partially filled in. Sometimes it's completely filled in, but they're like the student made a mistake. Find the mistake. I can tell you this, okay? A 3 by 3 5 is always going to be in the middle. Always. Like, if you want to add that to your study sheet, I don't know, it might come in handy. If it's a 3 by 3 magic square, it's always 5, and the sum is always going to be 15. Okay? But they tell you that. The one year where they didn't tell you what the sum was, it was a 4 by 4. Okay? 4 by 4. They had filled it in completely, and they were like, figure out one number is wrong, or like 2 numbers are wrong. They're in the wrong spot. Figure out what that is. So what you had to do is you need to figure out what is the magic sum. What is that magic sum? So just start adding, and all of a sudden you realize, oh, it's always like a bunch of these columns, bunch of these rows add up to this, so that must be the magic. And which ones are not letting that happen? And it was just a swap away from fixing it. Just had to swap 2 numbers, and you got it. Can I just ask you this? Please don't leave those empty. Don't leave those blank. Try something. I've had students, they did everything. They're so done, you're so tired. They don't even try it. I would say at least give it a try. Like an honest try. Don't leave those ones blank. One year it was like 2 sprockets. You know, sprockets are like what your bike has, where the chain is around. They had 2. They had one that like goes like this, and then a bigger one. It's really bad. But this one was turning that way. Which way would this be turning, this wheel? If this turns that way, this one turns that way. So they had like a chain reaction. They had like 6 of them. And they asked everybody, what's that last one? Which direction is the last one spinning? So all you had to do is you had to follow this puzzle until that last one, and you got it. 1 mark, right? So nothing to lose, much to gain if you try it. If you don't even try it, then you lose everything. So I'm going to try every once in a while to sneak one in. And maybe at first I won't put them on a test. I'll just put it like on an AC or something so that the risk is very low. But yet one more thing that you need to know for the exam, or be prepared for. Okay? It's designed that you can do it without previous knowledge. That's what they tell us, right? But I think you should still have seen a couple, so you're like, oh, okay. I knew that this was coming, I just didn't know what it was, right? So much talking, right? Just